Hi everybody, welcome back. So we got another one in front of us here. It is a Marantz 2325. We're just going to do a repair on it. This belongs to somebody and we're just going to check out the problem and see if we can get it working for them. What this thing's doing, so you can see it's going to make a liar out of me now and work. Look at the yellow channel after it's been running a while, and I can't decide right now if it's the knob, or if it's the pot, or if there's a bad signal transistor. It's working really well now. What do we got there? About 80 watts per channel right there. See, it's not doing it. So it was acting like the potentiometer was bad. When you'd rotate the volume, it would jump all over the place after it had been on for a little bit. It is not doing that now. Let's move some. Okay, that's the balance. It's dirty, but that's not what it was doing. I was getting crossover distortion and everything on the yellow channel. So let's keep, there it goes. There it goes. That is not a volume pot. Look at that. That's not the volume pot. I think we might have a bad transistor. So let's open it up and see what's going on. All right, we got the top off, and you know me, I don't like the crud and spiders. Well, cobwebs. We're going to clean this up a little bit and then we'll take a look. And of course, this is one of the ones that has that lovely glue that we all like so much. See it? So that doesn't mean the caps are bad, but it's that corrosive glue. So let's get it cleaned up and let's take a couple measurements. Okay, skipping ahead a little bit here. I took this all apart and I meticulously cleaned all the pots and controls for the most part. Gave it another little test run, and lo and behold, the problem came back. Came back one time, and it did it pretty substantially, so I was able to see that it definitely is not a dirty control. So the next thing I did was printed out the schematic. I started looking at this circuit a little bit. This stuff here is all the protection circuit, you know, for overcurrent sense and everything. But back in here, we have a few. When I look at these this transistor complement, I see a 2SA 720 and I see a 2SC 1318. And these guys are kind of known. They're notorious for having, what's that? These ones here, 704 and 705. Those are kind of notorious for having that shot noise and kind of arky-sparky snap, crackle, pop. And I'm wondering if maybe these are causing the problem. So what I did was I got the oscilloscope and I connected to the transistor, and it's on this channel over here, which is the left. And I went to check these, which I was not able to get it to do it again after I turned it off, left it off for a while, turned it back on. It seems to only do it the most when everything's cool. I tried some freeze spray and everything, and it will not do it now. So I couldn't do it, but I also noticed, and I'm sure you can see it from here, a little bit too close, huh? There we go. And you can see we have corrosion on this resistor here. And looking through here, there's some crustiness throughout the amp. Even after cleaning it up, the power supply, I noticed that some of these little transistors in the regulator circuit are kind of buried in that glue. And you know how we talk about the glue all the time. And one of the ways to tell if it's going to start getting corrosive is if it starts getting hardened. And this glue, you can see, is hardened. It's not it's not pliable anymore. When that happens, that's when it starts eating things away on the board, like the leads on the transistors and so forth. When I look at it, they're getting kind of tarnished here. So neither here nor there, it's only doing it on one channel. So I don't believe this is the problem over here, but it's definitely something that's going to need addressed. What I'm really kind of leading up to here is there's a few things that probably should be done. This is a very, very desirable receiver, the 2325. Most of you know its reputation. And I think this is going to be worth more than just cleaning the pots and replacing one bad transistor. So I'm going to reach out to the owner of this and ask him just how far he wants to go with this. Just so you all know, I don't do this kind of work for a living. I'm doing this through a relative of mine, and as a favor to them, but it's still going to cost them some money to do this if they want to do it, just because of the parts and the work that's going to be involved. So I am going to reach out to him, see what he says, and then we will service this receiver based upon what he says. So we'll be back at that point in time. Okay, I have been monitoring this thing for a long time. It's the next day, and I've tried both letting it cool down overnight and immediately in the morning turning it on when it's ice cold and everything's been sitting. I had no failures. I then let it warm up for a long period of time. Still no errors. I tried heating it. I tried some freeze spray on the transistors. Still no failures. That little bit of jumpiness you see there is because I have the high impedance of the scope input. I'm using the ×10 probe, and I'm on a very small scale of 100 millivolts per division, and it's the point that I'm checking in the amplifier. It's picking up noise. But as you can see over here, I think I have everything in shot. I have a very clean signal, and both channels have the same output, and the DC offset right here is very low. There's a little bit of offset, obviously, because I have that probe in there. It's probably throwing some things off a little tiny bit, but even with that, it's 60 millivolts at idle. And really all I did was clean all of the terminals. These boards have plug-in connectors, as does the driver tone control, volume control board. And I cleaned them. And I really haven't done anything else. I haven't touched anything yet. I haven't changed any components. We caught a recording of the one time you saw it fail, and it did it about 3 or 4 times yesterday, and it has not done it since I've cleaned things up. And I don't know if it was just a tarnished connection or something, or if we just have a really, really intermittent transistor. But I really want to test this for a long time and make sure that we don't have any problems with the transistors. Again, this is not a restoration job that I'm doing. This is a checkout and repair for someone, and I don't know that they really want everything replaced in this, because that's going to get into a lot of time and parts and so forth that I don't know that they want to invest in. I haven't heard from the customer or from the owner yet. So with that in mind, I'm just going to keep working on it. We're just going to keep testing it out, and if it goes all day without any more failures, I'm probably going to be inclined to button this thing up. I would recommend to the owner that we rebuild this power supply, simply because that glue has eaten away at some of the terminals. I'll see if I can get you in there. You can see it. You can see down in there. I'm not sure if I have a good enough angle. See it? See how that's kind of eaten away at those terminals of those transistors, and you can see how that stuff is just eating away at the leads of that resistor. And you can see that we have some tarnish. Where are we at? Where is it? Right there. I don't know if it's focusing or not, but see how that's tarnished? And this one is starting to tarnish over here. Not sure if you can see it. So at least those tarnished components that are corroded components should be replaced. And I might do that, and we're going to call it a day on this one. There was 3 bad panel lamps. I replaced them, cleaned it up generally. This receiver's been kept, indoors, in a good environment. It just had some dust in it, as you would expect something from the 1970s to have. So we just gave it a little dusting and cleaning. But, well, I'll test it some more. If I see anything else, I'll come back, and if not, we'll button it up and we'll do our testing on it, just to see how it performs. Okay, after a quick adjustment of R713, which is this pot right here, you can see we have our DC offset down to 1 millivolt. Beautiful. It's holding very well. So I'll do the other one on camera so you can see it. I know a lot of people that have seen DC offset adjustments a million times, but I know some people that have these specifically like to see this for their particular unit. So I'll do it because it only takes a minute. Okay. Now what I'm going to adjust is this pot right here. And let me get this somewhere where you can actually see it. Okay. Right. And this one's not bad. It's 32. Let's see if Tony goes the wrong way again. Okay, this pot's a little bit dirty. It needed moved. Okay, getting close. There we go. As long as it's floating around that 1 millivolt range, it'll be good. So you just measure across the speaker terminals, and it should hold pretty well. Let's do the bias while we're in here. Okay, we're now connected. All we're doing is just measuring across there. They want 15 millivolts, which represents 75 milliamps of idle current on the transistors. This one is idling a little bit low at about 9 millivolts. And when we look over at the other channel, as I bump the camera, it is also running somewhere around 8 to 9 millivolts. Don't worry about the minus sign. It just depends on which way you connect the leads on the resistors. But as you can see, they're both idling in that 8 to 9 millivolt range. So they're biased a little bit cool. And when we go to do our tests, I think this is going to be okay with this. We're going to leave it at that. I don't want to increase the idle current any higher than I have to, because all that's going to do is it's going to make the amplifier idle hotter. And why would we want to generate heat when we don't need it? So unless we have some sort of crossover distortion at very, very low volume levels, we're not going to worry about it. We're going to leave it where it was set. So really the only thing we had to adjust was the DC offset a little bit. And that was a very simple alignment, as you could see. So again, I'll do some more testing. If no failures, we'll do our tests on the, for the frequency analysis and distortion and things like that, just because it's fun. What you see right here is a 50 millivolt signal being generated across the dummy load, the 8 ohm dummy load resistors. So 50 millivolts That's a tiny, tiny volume. You barely hear. It's not going to be very loud. If you do the math or just read the display, it comes out at, when you have 50 millivolts, you're talking about 300 microwatts roughly of signal into the dummy load. So this would be an extraordinarily low volume, and you can see there's absolutely no crossover distortion whatsoever. So I see absolutely no reason to increase the bias. Okay, I went ahead and rebuilt the power supply. This is one of those really high quality relays with the bifurcated contacts, and it even has a plastic divider in between the right and left channel contacts, so it is a really high quality relay. It was very clean. There was no, I did check the contacts and kind of run the little paper card with the cleaner on it, but there really wasn't any dirt that came off of it, so that was good. We're now ready to try out the power supply, and I have it on the dim bulb tester because you never know. I double, triple check everything, but if you get a capacitor or a transistor in backwards or something not right, you surely don't want to burn up the, the new board and ruin all your work. So here we go. Okay, and that's a 12 volt supply there, and we're looking for a 19 volts, and that's what I would expect because we're on the dim bulb tester. And we'll move over to the, I believe it's a 30 volt supply or something like that, and it's going to be low, and it's low. Let me see. Yeah, it's very low, and it should be a 35 volt supply. Oh, I'm sorry. Yeah. No, the other one was 35. This one should be the 19 volt supply. So the 19 volt supply is 10.5 volts. 35 volt supply is 16.7 volts. And I'm just running on a 40 watt bulb, which is not allowing the power supply to come up. Let me bring it up a little more with one other bulb. And I heard the relay kick in. That's great. And look at that. We still have the bulb, so you're still going to be a little tiny bit low, maybe. But 35 is 34 now. 19 volts is 19 volts. And those 3 transistors that were all covered with goop have now been replaced with same characteristics, but a lot heavier, a lot higher power rating. So the gain and everything was the same because those transistors are actually part of the protect circuit. And if we look down here, you can see these are important. You don't want them to have the wrong gain or anything like that, because these are what sense and determine when this relay comes in for the time delay and for all that sort of stuff. So we want those to work, and it does. So let's try the amp out once again and see if it works. Amp is on. We're on full power. I have the signal generator on, and let's see what we get. Uh-oh. Look at that. It's doing it. It's doing it. Huh. All right. Turn on the scope. See if I can catch this before it fixes itself. It's so fast when it does it that you can't see it do it. I just want to see if it's, let's see, right here. And there you have it. Right there at that transistor. Okay, let's look at the H703, and I want to look at the emitter of that. Try to do this without shorting anything. And sure enough, Now it came back. So as soon as I touched that H703, everything came back to life. So let me show you where I was. I'm sorry I had to do this because now it fixed itself again, and you can see it's working just fine. And where our problem was, or seems to be at least, is these little transistors down in here. So you have your differential input pair, which are thermally coupled. They're tied together with that heat shrink. You have your current source at the top, and then you have the two drivers, or little voltage amplifiers that come after that, right there. So I was testing right in this area here, and that's where I was seeing on my other scope. I was using this one over here to see what was going on, and sure enough, that thing was almost flatlining, and then when it came back on, the waveform popped right on there. So it's at the front end of the amp. It's these little transistors. So those are what we're going to need to replace. I'm glad I was able to catch it, and we actually caught it on camera this time. Well, we've got our transistors replaced. We got a new match set here, and you've seen me match transistors in the past. I replaced these two. These are the ones that are kind of problematic, or they're known to be problematic, which is the 2SC1318 and the 2SA720. And I replaced them, if I can turn it to an angle that you can see it, with a KSA1220 and a KSC 2690. So 1220 and a 2690. And they'll perform the same, but they'll take a lot more abuse, which is good. And then we put another KSA 992 up here for the current source. And then we have the two capacitors that I replaced just because I had it apart here and might as well do it. So we're ready to put this back together and see if this took care of it. And if it did, we will do the other side as preventative maintenance, and also so that they match. Okay, we now have our noisy little oscilloscope set back up, and let's take a look and see if we fixed it. Got everything turned on, have the signal turned on. Looks like we have two good channels. Nice. We'll let this cook for a little while and make sure everything's okay. We're running it at about 47 watts per channel, 46 watts, something like that. Everything looks good. Alright, well, I'm going to keep testing this and let it run for a while. And hopefully our problem is all gone. I'm pretty sure it is. We saw it on the other scope. We saw that it was a transistor, and we replaced them. And that's about it. So I'm going to do the other channel the same way, just again, like I said, so the channels match. And once we do, we'll flip this thing over, and I think we're ready to do a couple of performance tests. Right, we are trying out the new camera stand here that I got. And the nice thing is it mounts on the right side instead of the left side, so I now have a lot more bench space. You can see over here without that big arm being over there. And it's a pretty sturdy stand. Kind of show you part of it. You can see here. But the little ball mount that the camera goes on itself is a little bit, you can see it's kind of wobbly, but if you don't bump it, it sits really still and it's really nice. So I think I'm going to like this. We'll see how it works out. I have the amplifier put back together. I have it turned on, warming up a little bit, get it to stabilize. As we saw in earlier clips, We have the bias and the offset set perfectly. And I checked the 35 volt supply, and surprisingly it was dead on 35 volts, even though I had replaced the capacitors and transistors in it and everything. Everything fell into place, so the transistors I replaced with were very good matches. So we rebuilt both amplifiers, and you can see over here just the two caps. These transistors here, we put new matched pairs in here for the differential inputs. I did not replace these big transistors. They rarely ever go bad, so I'm not going to worry about that. We repaired these resistors on both amplifiers, and again did the bias and offset, so we're good. We're going to check our wattage, and we're going to check for total harmonic distortion. Let's see where we are, and I'm sorry about the wires in the way, but there's just so many things here we have to have connected. All right, I'm gonna have to, this is gonna go off scale if I don't move it here. Let's see what we get. There's 125, 127 right there, and right around 100, you can see around 160, 150 we're clipping, and we clipping almost perfectly on both sides. All right, let's move the camera over here, and I still got to learn how to drive this thing a little bit, this camera stand, and let's see what kind of distortion we get. And wow, there is 125 watts per channel. And if you recall, well, maybe you don't, I didn't show you, in the service manual there's 125 per channel all day long. And that's exactly what they said it should be, is 0.03% THD. I have this set clear out to the 5th harmonic. That's excellent. Let's reconfigure the setup here, and let's measure our frequency analysis. All right, next thing I'm going to do is, we were talking about what we were going to look at next here in the last clip, but I'm going to show you something that I found out about this receiver that I think is very interesting. So we'll go back to our dummy load, and you can see that I have a signal being fed in. It's a 20 kilohertz signal right now. And again, both channels are extremely clean. We have a nice sine wave, and everything's looking good. I have a low signal going in there right now. We're only looking at about 3.5 watts per channel or so. Not a real high powered, doesn't matter. So you can see there. And let's go back up here now and do the frequency analysis. And I haven't done frequency analysis on a whole bunch of equipment yet. So this was really interesting when I found this. And if you take a look, you can see it's the blue line is the actual input versus output, the actual gain to see if it's linear at the different frequencies. And you can see how linear it is. It's a pretty flat amp. But do you see the red line? Take a look at that. Now, when I first saw this, it kind of made me pause for a moment to think about why I'm seeing that and what that means. This red line is actually showing you the phase relationship of the input to the output of the amp. So, in other words, what it's looking at is you're taking the waveform. Let's go here for a minute. And you're looking at the signal coming in, which is this yellow, this would be what's going into the auxiliary input of the amplifier. And then this blue, which is what's coming out of the speaker terminals into the dummy load. And if you can see, there is a little bit of phase shift there. You notice that? And believe it or not, the output of this amplifier is inverted from the input. In other words, the polarity on the input is opposite than what's coming out of the output. So it would be like if you took your speaker terminals and put the positive on the negative and the negative on the positive. So what's happening is whenever the signal swings high on the input, that's your auxiliary input jack, you're going to have a negative going signal on the speaker terminal. So positive going at the auxiliary gives a negative going over here. Now you are going to see a little bit of phase shift, which you're seeing here at 20 kilohertz from the amplifier, and that's normal. You'll see that. But this amplifier is actually out of polarity. It actually inverts the phase or inverts the polarity, however you want to word it. So if I go to this channel and I invert this, you can see they're much closer to being in phase now. And as you go down in frequency, they'll almost fall right on top of one another in phase by inverting one channel from the other. Really interesting, and it doesn't matter which channel. So if I move this over to the other channel, I find this really interesting. So what I'm going to do now is we're going to we're going to go back up to the Rigol DG4162 signal generator. And I'm just going to look at the output here, and we're going to look at the output of the signal generator versus the output of the speaker terminals and make sure that the amplifier is really inverting the signal. Okay, I now have, you're looking at the signal coming out of the signal generator, and the blue line is going to be, the blue trace is the signal coming out of the speaker terminals. And you can see they are exactly 180 degrees out of phase from one another. So the polarity is reversed right now. Now, what I'm going to do is I'm going to disconnect the output from the dummy load from the speaker terminals, and I'm going to connect it to the output of the preamp. And we're going to see if the preamp is what's inverting the signal or if the amplifier module is what's inverting the signal. Okay, let's make you dizzy for a minute so you can see what I'm doing now. So I was looking at the dummy load, you know, the 8 ohm dummy load from the speaker terminals. We're now going to look back here. See if I can show. Okay, let's go back here. And you can see I am plugged in right here. And that's going into the preamp out that you can see under the antenna here. So you have the main amp in and preamp outs. That's where we're looking. So we're actually looking at the preamp, and we're bypassing, or we're looking at it before it goes into the power amplifier section. So again, if this signal is being inverted there, we should see it still be inverted on the scope now. So here we go. This is our signal generator. And look at that. So the preamp circuit of this receiver actually inverts the signal or swaps the polarity of the signal around, which is weird. I don't know that I've ever seen that in one of this era of receiver before. And it's both channels are doing it. Okay, let's try to demonstrate why this thing is inverting the polarity. We have these silly little op amps in here, and these are unobtainium nowadays, and I guess there is a company making like a discrete component replacement for this, because these little chips, and they're called BA312s, and I think it's an NTE 1332 or 3132, something like that. But anyway, these are those long, you can see they're just chip that only has 7 pins and it's all on one end. And they're down in here. There's one here and one here. And this is kind of like a buffer preamp. And it goes from there through the tone control, from the tone control to these 2 transistors, and then out to the amplifier, to the main power amplifier. And this little connector here is the edge connector right here on the board. And if we look, we can trace this signal all the way through here. So it comes into pin 2 of the chip, comes out of pin 6, and that's on both sides. And yes, I'm holding the schematic. I'm not posting it on a board, so it moves around and you'll get nauseous. So it comes in, the signal comes in through this volume pot. So here's half the volume pot for one channel and the other half for the other channel. And we can see it come right in through these pins and into here. Then it goes out of the pot from the wiper up to pin 2, out of pin 6, through the tone network, and it's getting bypassed right now because we have the tone defeat on. It'll go through this switch and then go through this other little buffer circuit and out. And you're going to see right here is where we're going to get the inversion. So because this is not an inverting amplifier. So now that you see everything, I'm going to be checking right here and here, which are the inputs to the potentiometer, to the volume pot. We're also going to go down here and we're going to look at the input of the chip and then the output of the chip. Then we're going to go up here and look at the output after those 2 little transistors. And I'm going to put you back up on the scope, and all the while we are going to be comparing it to that top signal, and you can see it right up there. And that's going to be what you're looking at right now, is the input to the preamp from the auxiliary input jack on the back of the stereo. Okay, if that makes sense. And this is an annoying camera stand in that it has a little rubber grommet and it drifts. And so it takes me a minute to get it lined up. So there we are. Okay, first thing, let's look at the potentiometer. And this is where it comes off of the auxiliary input jack and into the input of the pot. So there's one channel. There's the other channel. And you can see it's in phase right now. Now we're going to go into the input of the op amp, which is pin 2, if you remember. And I don't think it'll focus. I'm not going to, yeah, maybe it'll focus. Let's see. Pin 2. Can't see it, but I showed it to you. Pin 2. So here's pin 2 of the op amp. And I have to turn the volume up. And you can see it's still in phase, right? And let's make this a little more sensitive. It just makes it's a little bit jumpy, but that's okay. And then the output of the chip, it's still in phase. See that? Then we go clear to the end on the other side of the, so those are what's going into the input of those 2 transistors. We're going to come out of the transistors and look at that. I'm going to get on a test point, and you can see now it's now out of phase. So what that's showing us is that these transistors right here are actually an inverting buffer circuit. So it just comes out of the tone control through here and it's inverting, because you can see you have an NPN transistor and a PNP, and as this goes more positive, this side up here goes more negative, so it's an inverting circuit. And then you have these capacitors, these coupling capacitors, and they just go around up here and out to the output of the amp that goes out to the amplifier, goes out of the preamp into the amplifier. So it's really interesting, and I don't know why they designed this thing to invert the signal, but they did. So any of you Marantz professionals out there have a comment, that would be awesome to know that. But it's very interesting. Okay, it is the next morning, and since it's Thanksgiving over here in the States, I actually have a day off. So while everything is upstairs cooking and started, I thought I'd come down here and finish this up. Full disclosure, I couldn't wait, so I listened to this receiver last night for quite a while with a lot of different music and selections. Tried it with and without some tone control adjustments, and this has the absolutely quintessential Marantz bass sound. Any of you that have heard this vintage of Marantz equipment, you'll know what I'm talking about. The bass is so clear and so powerful. It's a signature of this equipment, and this one really has it big time. So I was really pleased. It sounds very good. I kept the original incandescent lamps and replaced them, and because I kind of like that kind of greenish blue light glow that it has. I also like, the LEDs that are a little brighter blue. I like that look as well, but this is so nice, and I wanted to keep it like that for the owner. I'm sure he would appreciate that as well. Now let's talk a little bit about what we found when we did the frequency analysis. As you recall, when we did the frequency analysis, we saw that funny looking, it started out at minus 180 degrees out of phase, the input versus the speaker outputs. And then at a certain frequency, around 700 hertz or so, it jumped straight up and it went to positive 180 degrees out of phase. It was still 180 degrees out of phase. What you were seeing was, first of all, that this amplifier inverts the signal. So anytime there's a positive going signal going into the input jack of the receiver, you get a negative going signal out of the speaker terminals. And that's called inverting the signal. Now, why did they do that? Well, I really don't know why. I don't know if that was just a result of the design of this circuit. So this is your tone control section, and they use this, like I said, this funny little BA312, and in its day, it was considered a high quality, low noise op amp, a small preamp chip. And I'm sure it was cutting edge for the time. But of course we have much better components today. And we traced the signal through here, and we found that this does not invert. It is a non-inverting amp. It goes through the tone control section, and it goes through this little buffer circuit right here. And this is where the inversion takes place. So they very purposely made this an inverting circuit. Now, there's a lot of debate online, and if you go online and you try to look up Marantz inverting signal, you won't find anything. At least I couldn't. Even I went to DIYaudio.net, I went to Audio Karma. None of them seem to talk about this that I could find anyway. Maybe some of you have seen this. So I don't know how aware anybody is of that. And I would have to go back and actually look at some of the other Marantz gear to see if they also invert the signal. I know some preamps, especially high-end ones, have a button that allow you to either invert the signal or have it pass through uninverted. And supposedly it has some sort of, sonic value to it. I don't know. I have a really hard time with that, because what goes into your speakers that you hear that creates the sound pressure that your ears pick up is AC. In other words, after the first half cycle, the air pressure is getting more and less in your ear. It's a wave, and it really doesn't care at what point it starts after that first initial pulse. So I might be able to buy into the fact that for something, for one half cycle there might be a difference. But I even have a hard time accepting that. Now, there are people who claim, and they, that there is a difference in sound. I've read some articles where people say the sound stage gets wider, or it sounds more present up front, and so forth. I have tried this, something that a lot of people will try on a high-end system. And I worked in an audio store, by the way, back when I was in college, and the owner of the store was an audiophile, and he was exceptional at his job. And one thing he did do when he'd set up a high-end system for demonstration is he would reverse the speaker leads at the speaker terminals, and he would try it straight through and inverted, regardless of whether the system inverted the signal or not. And he claimed that he could hear a difference in the sound. So I tend to not doubt that, because he was not the type of person that was into snake oil and placebo effect things. He was a very sensible kind of person. And so that's why you hear me in a lot of the comments I make about things where, people will get down on audiophiles and people who are into listening to systems like that. I don't do that, because some of the points he made at that time made sense to me, even though perhaps I couldn't hear them. Maybe my ear is not trained to listen to things like that. Or maybe the gear that I listen to is just not of the quality that it would make enough difference that I would notice. I don't know. Neither here nor there, it doesn't matter. But it's just interesting that this amplifier does this. I up until I used that application on the MDO 2204, I never really lined up the input signal and the speaker terminal output signal and to see if they're in phase or if they're, out of, phase with one another, inverted. So it opens up a new question. How many pieces of audio gear actually invert the signal from the input to the speaker terminals? I don't know. I'm interested in this stuff because it always fascinates me why people design things the way they do and how they work. So anytime I have an opportunity to learn something new like this, this is what I go through in my mind, trying to figure it out. Anyway, I'll play something on this. Obviously, you're going to hear a lapel microphone. You're not going to hear this beautiful amplifier, but we'll play something and we'll end it with that. And as always, I wish you all peace, joy, happiness, and good health in your lives. And today is Thanksgiving in our country, in the United States. We give thanks for what we have, and I give thanks for all of you subscribing and commenting and all the things I've learned. I learned so much off of that last video on that tuning unit, the Strobomatic by Kahn. Wow, I got a real education from all of you, and I appreciate it. I thank you all, and well, as long as we all can work together, I'm happy to do these videos for you. So until then, take care, wish you all well, and let's listen to this thing. Okay, I have a song queued up here from the YouTube audio library that we all know and love. It is called, this is a new one here, Nothing on Me, and it's by Patrick Patricos. I hope I'm saying that right. Anyway, that's what we're going to listen to. And again, everything's flat. I have the tone defeat turned on. There's no loudness switch. And I know you can't hear it through a microphone, but you'll have to trust me. This thing doesn't need anything. It doesn't need tone controls. It doesn't need a loudness. It just sounds perfectly balanced as it is. And that's the thing I love about this vintage equipment. All right, let's play Nothing on Me. You never know what you get with this stuff, do you? Let's see how this one is.